a second, I need to get my story straight. My friends are in the bathroom, getting higher than the Empire State. My lover, she's waiting for me just across the bar. My seat's been taken by some sunglasses.
I can't do this.
Do what?
I can't go out with you.
Why not?
Because you don't understand the laws of the conservation of mass, and I can't date a dummy.
Wait, what?
Problem. As you see here, we have a standard combustion equation. Carbon monoxide, or CO gas, will react readily with oxygen, O2, to form carbon dioxide gas. In order for this to work, though, we've got to balance this equation. So let's see how this works. First thing we do is identify the elements on each side. We've got a carbon here and an oxygen. On the other side, another carbon and another oxygen. So now let's count up the elements. How many carbons? One carbon. That's right. How many oxygens do we have? Well, we've got one there. We've got one here, but what does that little 2 mean? That means it's a binary oxygen. 2 oxygens bonded together. So 2 plus 1 gives us 3 oxygens. On to the other side. 1 carbon, and again, 2 more oxygens. But wait, you say, this doesn't match up. We need to get these to match. So, carbons are equal. Oxygens are off balance. So what can we do? Now we have a balanced equation. By placing a 2 in front of the carbon monoxide, we're able to get 2 carbons and 4 oxygens. 2 here and 2 here. Then by placing a 2 in front of the carbon dioxide, we're able to get 2 carbons and 4 oxygens. Now we have a balanced equation. So let's see how this conservation of mass works. Conservation of mass says that what we start with, we end with. So here we have a mass of 225.7 grams. Now if I were to flip this upside down and mix the 2 chemicals together, we now have, oh my gosh, 225.7 grams. Exactly what we started with. That's conservation of mass. I'm Bill Nye.
When you take the classes with TEK SE C.08, got to remember about these balanced equations. Being sample size have the same atoms, and build the equations, get the job done. We come to one conclusion, it's a conservation of mass. It's such the mass is the same at the beginning as it is in the end. This right here is cake batter. It's plain, stupid cake batter. It's white, just like me. Bang! Spice up that. This stuff is me. I'm Dustin. According to the law of conservation of mass, the mass of this cake batter will remain constant after the cupcakes are baked. The weight of this right here is going to be the same weight as this right here. Conservation of mass, You think you understand conservation of mass? Let's try it out and see if you do. The correct answer is F because the mass stays the same through the experiment. That was great. Let's try another one. Answer this next tax question. Answer is C because you have to have the same amount of reactants on the left as the same amount of products on the right. Because this is thermal and we're not dealing with heat. H is wrong because we don't have velocity, and J is wrong because covalent bonding happens in the periodic table of elements. A, B, and D are wrong because the total amount of grams on the product side does not equal the total amount of grams on the reactant sides. The law of conservation of mass says it has to. See you later, pass the tax.